Hello students. Uh, in this video, I'll explain assignment number 3 of first chapter. Uh, Numericals are based on empirical and molecular formula. Calculate molecular formula for hydrocarbon, which contains 90% carbon, vapor density is 40. If you remember, I told you these numericals have to be solved in tabular form, right? I'll be drawing table once, but using it multiple times. Elements, percentage, atomic weight, atomic ratio, simplest ratio, whole number ratio, and empirical formula. I'll keep on telling you, you might have forgotten. It contains 90% carbon. It means carbon is 90%, hydrogen is 10%. It's a hydrocarbon, it means no other element is present. Atomic weights are 12 and 1. Atomic ratio is percentage divided by atomic weight. So 90 divided by 12. This will be, let me tell you, this will be 7.5. And this, by dividing, this will come 10. Now, simplest ratio is divide these values by the smallest value. So 7.5 divided by 7.5, 1. 10 divided by 7.5 will be 1.33. Now, this column is to be used only if minimum one of these values is a fraction. Now, this one is a fraction. Now, we'll multiply both these values by such a smallest number that they are all converted into whole number. So, multiply by 3, it becomes 3 and 4. So, empirical formula is C3H4. Now, from empirical formula, we can calculate empirical formula weight, and empirical formula weight will be C3H4. You can calculate by using atomic weights. This comes out to 40. Now, molecular weight, N is equal to molecular weight divided by empirical formula weight. Molecular weight is vapor density into 2. That is 80 is the molecular weight. Empirical formula weight is 40. So value of N is 2. It means molecular formula will be C3H4 into 2, that is C6H8. Second numerical. A compound molecular weight 248 contains 18.55% sodium. Sodium 18.55%. Atomic weight is 23. 25.81% sulfur, 25.81, atomic weight is 32, and 4.03% hydrogen. Atomic weight is 1. Now, if you add all of them, total is not 100. It means leftover is oxygen. In this case, 100 minus all these will be oxygen, and that will be 51.61%. Atomic weight 16. Now I'm directly writing values. These percentages divided by atomic weights will be atomic ratios, and values will be 0.806. This has to be, a calculation has to be shown in the exam, right? But I'm just writing values. This will be 0.806, third will be 4.03, and last will be 3.22. Now, all of them will be divided by the smallest value, that is 0.806. This will be 1, 1, 5, and 4. So this next column is not required because all values are whole numbers. Empirical formula will be NaSO4 NaSO4H5. Now, on the basis of this, empirical formula weight will be 124. Now we are given that molecular weight is 248. it means value of N will be 248 divided by 124, that is 2. So molecular formula will be double of this. Double of this will be Na2S2O8H10. Now, towards the end of the numerical, it is given calculate molecular formula of the compound and express it assuming all hydrogen atoms of the compound to be present as water crystallization. See, there are 10 hydrogen atoms. 10 hydrogen atoms will form 5 molecules of water crystallization. And for 5 water, naturally 5 oxygen atoms are also required. So what is left? It will be Na2SO3, because 5 molecules will 5 atoms of oxygen will go into water crystallization. Dot 5 water. So Na2S2O3, 5 water. This compound is sodium thiosulfate. Next, third numerical. A compound contains carbon, hydrogen, and nitrogen in 18:2:7 ratio. Calculate molecular formula. Vapor density is this much. See, when you are given ratio, then there's no need to calculate percentage, although you can calculate percentage, but there's no point wasting time. In the column of percentage, you can directly use ratio, right? But in that case, remember, there's no oxygen. So here it is, carbon, hydrogen, nitrogen, carbon, hydrogen, nitrogen, ratio is 18:7. Then atomic weights 12, 1, 14. Proceed in the same manner as I told you in previous 2 numericals, right? I'll cut short now and you'll get the empirical formula. So follow all steps. Empirical formula will be, let me write, empirical formula will be on the basis of answer, half of it. C3H4N. C3H4N. Empirical formula weight will be, you can calculate empirical formula weight will be 54. Now, N will be vapor density into 2, that is molecular weight, divided by empirical formula weight 54, N is 2. So molecular formula will be double of this, that is C6H8, N2 is the molecular formula. Numerical number 4. 12.6 grams of iron gave 18 grams of its oxide on reaction with oxygen. Calculate empirical formula. Now, again, in this case, there's no need to calculate percentage of both the elements, that is iron and oxygen. You can directly use masses and proceed in the same manner as we did in earlier numericals. So it contains iron and oxygen. Iron is 12.6. In place of percentage, I'm writing mass of iron, 12.6 grams, and gave 18 grams of oxide. It means 18 minus 12.6. That difference is oxygen. So 18 minus this, 5.4 grams. Atomic weights 56 and 16. Follow same steps I told you earlier. Empirical formula will come out to Fe2O3. Right? We have to calculate empirical formula only. This is the final answer. Numerical number 5. Calculate molecular formula of the compound containing 12.7. Now, percentages are given. Containing 12.77% carbon. Atomic weight 12. Bromine is 85.1%. Atomic weight is 80. And hydrogen is 2.13. Again, follow same steps. You'll get empirical formula. Empirical formula will come out to CH2Br. Now, we are given that 3.76 gram of the compound occupies 448 cc of volume at STP. Now from this data, we'll calculate molecular weight. See, what is molecular weight? Molecular weight is weight of 1 mole of the compound, right? And 1 mole of any, sorry, 1 mole of any gas will occupy 22.4 liters of volume at STP, right? So I'm writing here, you have to understand. Here we are given 448 cc is the volume occupied by 3.76 grams of compound. Now, I'm speaking and then I'll write 448 volume weighs 3.76 grams. One weighs 3.76 grams divided by 448. 22.4 liters means 22,400 cc will weigh how much? So this is the weight of 1 mole of the compound. That is nothing but molecular weight. So this molecular weight will come out to 188. And this empirical formula weight will be half of this, 94. N will be 2. It means molecular formula will be double of this, C2H4Br2 will be the molecular formula. Now the last numerical. A crystalline salt lost 51.22% of its weight when strongly heated and became anhydrous. It means out of 100, 51.22% was water crystallization. Anhydrous salt means after loss of water, whatever is left that is without water means it's called anhydrous salt. Anhydrous salt contains 20% magnesium, 26.67% sulfur, atomic weight 32. Now, if you add these two, it is not 100. It means leftover will be oxygen. Oxygen in this case that you can find out 46, 47, 53.33. Use same steps, calculate empirical formula of anhydrous salt. This empirical formula will come out to MgSO4. Empirical formula weight is 120. Now, we are given molecular weight of anhydrous salt is 120. It means the value of N will be 1. So empirical formula and molecular formula of anhydrous salt will be same. So empirical formula is equal to molecular formula is equal to MgSO4. Hydrated salt. Let us say the hydrated salt is MgSO4 dot X water. So basically we have to calculate the value of X, right? We have to calculate the value of X. Now, this is 120. This is 18X. Now, it says, wait a minute. Now, it is given that hydrated salt lost 51.22% of its weight on heating. So 100 grams of MgSO4 dot X water contains MgSO4 is equal to water is given 51.22% is loss in weight. So out of 100, 51.22 grams is water. Leftover is anhydrous salt. So 100 minus this will be 48.78 or something. Yes, 78. Now we'll convert both of them into number of moles. So MgSO4 will be 48.78 divided by molecular weight 120.4. And water will be 51.22 divided by 18. This will come out to 2.84. It means 0.4 mole of anhydrous MgSO4 combines with the 2.84 mole of water. So one will combine with how much? That will be the value of X. So 0.4 mole MgSO4 as water is equal to 2.84 mole. 1 mole has how much? Calculate karo. This will come out to 7. It means value of X is 7. Formula is MgSO4.7 water. That's all. Remaining questions are ABCD type questions.